Few months ago, I had one of those quiet little disasters that every person running their own service eventually has. Something broke in the middle of the night, the kind of thing that leaves a clear warning in the logs hours before it actually falls over. And the warning was right there. It had been sitting in my logs the whole time. I just never saw it, because it was buried under tens of thousands of perfectly normal lines that scroll past every single hour. That is the real problem with logs. It is not that you have too little information. It is that you have far too much, and the one line that matters is hiding in plain sight. So I built a small AI assistant whose only job is to watch that fire hose, ignore the boring stuff, and tap me on the shoulder when something genuinely deserves my attention. Let me walk you through how it actually works and where it still gets things wrong. Fifi's the problem is too much signal. Let me describe what watching logs by hand is really like, because if you have never done it, the scale is hard to picture. A handful of small servers can easily produce tens of thousands of log lines an hour. Almost all of it is completely routine. A request came in, a request finished, a backup ran, a health check passed. It is the digital equivalent of a hallway full of people all murmuring at once. Somewhere in that murmur, occasionally one voice says something you really need to hear. A disk is filling up. A service has started quietly retrying and failing. An unusual number of errors just appeared from one corner of the system. The traditional answer to this is alerts. You write rules that say, if you ever see this exact phrase, wake me up. And those rules are great, right up until the problem is something you did not think to write a rule for. You cannot write a rule for a kind of trouble you have never seen before, and the worst outages are almost always the ones you did not see coming. And there is a second trap hiding in pure rules, which is that they only ever look at one line at a time. A rule fires or it does not, based on that single line in isolation. But a lot of real trouble does not live in any one line, it lives in a pattern across many of them. A single slow request is nothing. 100 slow requests creeping up over an hour is a server about to fall over. No individual line in that hour is alarming enough to trip a rule, so the rule stays silent right up until the moment it is too late. That gap between what a rule can see and what actually matters is exactly the hole I wanted to fill, what I deliberately did not do. Now here is the mistake I want to steer you away from, because it is the first thing everyone reaches for. The obvious idea is, I will just pipe all my logs into a big language model and let it read everything and tell me what is wrong. Do not do that. It is slow, it is wildly expensive at this volume, and it is genuinely overkill. You would be paying a clever, costly model to read line after line of a backup completed successfully, which is a spectacular waste. The model's attention is the expensive resource here, and you do not spend an expensive resource on work that a simple free rule can do in a fraction of a second. So the whole design is built around one principle. Let the cheap, dumb, reliable stuff handle the easy 99%, and only spend the model on the small slice that is actually hard to judge. That one decision is the difference between a system that cost me pennies and one that would cost more than just hiring it out. I see people get this backwards all the time. They get excited about how smart the model is, so they want the model touching everything, and they end up with something slow and expensive that mostly reads lines saying nothing happened. The skill is not in using the model more. It is in using it less and only exactly where it pays off. A good automation is mostly cheap, boring machinery, with one small, well-placed, expensive part doing the work that nothing else can. That ratio is the whole game. The cheap filter comes first, so the first layer is not AI at all. It is plain, boring, old-fashioned filtering. Before anything reaches the model, a simple set of rules throws away everything that is obviously fine. All the routine success lines, gone. All the chatter from health checks that passed, gone. And at the same time, a few hard rules catch the things I already know are always serious. If a database connection drops, I do not need a model to tell me that is bad, I already know. So that fires an alert directly. This first pass does most of the heavy lifting, and it does it instantly and for free. Think of it as a bouncer at the door. The vast majority of log lines never even get inside the building. What makes it through the filter is only the stuff that is neither obviously fine nor obviously a known disaster. It is the ambiguous middle, the weird, the unfamiliar, the lines that might be nothing or might be the start of something. And that ambiguous middle is exactly where a model is actually worth its cost, where the AI actually earns its keep. So what reaches the model is a small, pre-filtered pile of genuinely odd lines, and now the AI gets to do the one thing it is genuinely better at than a rule. It judges. A rule can only match patterns it was told about in advance. A model can look at a line it has never seen before and form a reasonable opinion about whether it smells like trouble. I send it the suspicious lines, grouped together, and I ask it a simple question. Is anything in here worth a human waking up for? And if so, what and why? And it is surprisingly good at this. It notices when a normally rare error suddenly appears a dozen times. It spots a message that, while not on any of my alert lists, clearly describes something going wrong. It connects a few separate lines into a single story, the way a tired human reading at 3 in the morning often would not. It is not reading every line, it is reading the short list of maybes that my cheap filter could not make a confident call on, and that is a tiny fraction of the total. And because it is reading a small group batch instead of a single line, it can do the thing rules fundamentally cannot. It can see the shape of the last hour. It can notice that 3 different services all started complaining at once, which usually means one shared thing underneath them is sick. A human on call learns to read logs that way, in patterns and clusters and sudden changes, not line by line. That pattern reading is most of what makes a good operator good, and it is exactly the part one wanted the model to take over, because it is also the part that is impossible to keep doing by hand at 3 in the morning. Giving them the context to judge well, a model is only as good as what you tell it. So a big part of making this work was giving it the right context. On its own, a log line is just a cryptic fragment. So along with the suspicious lines, I hand the model a short briefing. Here is what this server actually does. Here is what normal looks like for it. Here are the kinds of things that have genuinely hurt me in the past. With that context, its judgment gets dramatically sharper. It stops flagging things that are weird but harmless on this particular system. And it gets quicker to worry about the patterns that have actually bitten me before. This is the same as the difference between a brand new hire reading your logs cold and someone who has worked your system for a year. Same eyes, completely different judgment, and the only thing that changed is how much context they were handed. Writing that briefing well took me more iterations than any other part of the build. How it reaches me without crying wolf. Now, the fastest way to make any alerting system useless is to make it noisy. If it pings you constantly, you start ignoring it. And an alert you ignore is worse than no alert at all, because it gives you a false sense of being covered. So I was ruthless about quiet. The model does not message me for everything it finds mildly interesting. It only reaches out when it judges that something genuinely needs a person, and when it does, the message is short and plain. Here is what I noticed. Here is why I think it matters. Here are the actual lines. No jargon, no wall of raw text, just a calm human sentence I can read on my phone in 5 seconds. Most days it says nothing at all, and that silence is the feature, not a bug. A monitoring system that is quiet 99 days out of 100, and right on the 100th is exactly what you want. One that cries wolf daily trains you to ignore the one time it is real. A real save it caught. Let me give you a concrete example of it actually earning its place. One evening it pinged me with a short note. It had noticed that one service was logging a slow response warning, not constantly, just a little more often than usual, creeping up over a couple of hours. None of my hard rules had fired, because no single line was alarming on its own. But the model saw the trend across many lines and flagged it as worth a look. I checked, and sure enough, a disk was slowly filling and quietly dragging everything down. I cleared it in 10 minutes, on my own schedule in the evening. Without that nudge, the boring version of this story is that it falls over at 3 in the morning, and I find out from an angry alert and a worse mess, the model did not fix anything. It just noticed, early, the kind of slow, creeping problem that hard rules are genuinely bad at catching, and that early warning was the whole value. Vidas Kunjidi Kamsilis. Let me be honest about the limits. So here is the honest accounting. Because the model only ever sees a tiny filtered slice, the running cost is small, easily a few dollars a month at my scale, but it is not free, and I want to be clear that the model itself is a paid service. The real risk is not money, it is trust. This thing is an extra layer, a second pair of eyes, and it absolutely cannot be my only one. It can miss things. The filter in front of it can wrongly discard a line that actually mattered, and then the model never even sees it. So my hard, deterministic alerts for the truly critical stuff, a database down, the disk completely full, are still there underneath, doing their dumb, reliable job. The AI sits on top of that floor, catching the subtler things the rules miss. It never replaces the floor. Anyone who lets a clever model become their only line of defense is going to have a very bad night eventually, and I would rather you heard that from me now. There is one more honest limit worth naming. The model can be confidently wrong. It can read a perfectly innocent burst of activity and decide it is a crisis, or wave past something that genuinely mattered. That is why every alert it sends me includes the actual lines it was worried about, so the final judgment is still mine, made in 5 seconds with the real evidence in front of me. I am not handing the model the keys, I am letting it point, and I am still the one who decides whether to look. So should you build this? Would I tell everyone to build this? Not if you run one tiny server that barely logs anything, because then you can just read it yourself and this is wild overkill. But if you are drowning in log volume, if the signal you need keeps getting lost in the noise, and if you have already got the obvious hard alerts in place and still feel blind to the weird stuff, then a thin eye triage layer like this is genuinely worth the afternoon it takes to build. Start with the boring filter, because that is where the real leverage is. Then layer a model on top for the ambiguous middle and give it enough context to judge like someone who knows your system. Do that and you go from staring at a fire hose hoping to catch the one bad drop to getting a quiet, sensible tap on the shoulder exactly when it counts. That is the whole build, from a wall of noise I could never actually read to a calm assistant that only speaks when it matters. I am going to keep showing the real unglamorous systems I run, with honest numbers and the failures included. If that is your kind of thing, subscribe and follow along because there is a lot more coming. Thanks for watching and I will see you in the next one.